Welcome to possibly the best presentation you will see all day, Mr. Chakran. So, for our project, we were given the problem whether or not Mr. Souza was speeding.
First, to do this, we had to find the scale. And to find the scale, we took measurements of the model and found those measurements. And then we divided that measurement by the actual length of Souza's car to establish a scale of 42.5. And then we multiplied that scale by the measurements of the scale model to get the measurements of the actual event.
So, the first step to solving whether or not Mr. Souza was speeding was to calculate his time of flight in the fall from the cliff to the ground. So, we would use the kinematic equation number 2, which is y equals vy naught t plus 1/2 at squared. And we can eliminate vy naught t because initial vertical velocity was 0. So solve for t is time equals the square root of 2y over a. So when you plug in all the numbers as shown, you get time to come out to be 2.559 seconds. And then after that, you must find the horizontal velocity as through the projectile motion. And to do so, you use the basic velocity equation, which is velocity equals distance over time. And you plug in numbers as shown, which then makes velocity come out to be 5.150 meters per second.
Then we need to find the velocity of Mr. Souza's car as he slid into Mr. Chakran's car. And to do this, we use the conservation of momentum equations. The initial momentum equals the final. And to do this, we would have the momentum of Souza's car plus the momentum of Chakran's car equals the combined momentum. And since Mr. Chakran's car was at rest, Mr. Souza's original momentum would equal the combined momentum. And then we solved the equation for Mr. Souza's original velocity and got velocity equals the combined mass times the final velocity, which we found before, divided by Mr. Souza's mass to get 8.142 meters per second as his initial velocity.
So the next part is to find during the skid, we find the frictional force and also the acceleration. So first, to find the frictional force, we use the equation mu k Fn, and in this case, Fn is equal to mg due to there is no vertical work. What am I doing? Failure. What I meant to say was the sum of forces in the vertical direction is equal to 0. So Fk, frictional force, equals the coefficient of kinetic friction times the force of gravity. So you plug in all the numbers, and for the coefficient of kinetic friction on a wet road, on average, is 0.4. So the frictional force comes out to be 9,800 newtons. So then, to find the acceleration, you would use the second law, which is the sum of forces equals mass times acceleration. Solve for acceleration, so sum of forces equals mass, and in this case, the only force in the horizontal direction is friction. So acceleration equals friction divided by mass. And it then comes out to be 3.92 meters per second squared. The initial velocity, next, we would do kinematic number 3, solve for v naught, and plug in all the numbers. V naught comes out to be 11.24 meters per second, which is equivalent to 25.14 miles per hour.
So, in conclusion, Mr. Souza was speeding because he was traveling at about 25.14 miles per hour, and the speed limit was only 20.